Planning meets optimization. The critical path method, CPM, is a project management technique used to schedule and track complex projects with multiple, interdependent tasks. It involves analyzing the project network, calculating the duration of each task and its dependencies, and identifying the longest sequence of tasks that must be completed on time for the entire project to finish on schedule. This sequence is called the critical path, which determines the minimum time required for project completion. Key characteristics of CPM. 1. Network diagrams or task dependency. Uses visual representations of tasks and their dependencies to understand the project flow. 2. Activity durations. Estimates the time required for each individual task. 3. Early and late start, finish times. Calculates the earliest and latest possible start and finish dates for each task based on its dependencies. 4. Critical path. Identifies the sequence of tasks with no slack time, meaning any delay in these tasks will delay the entire project. 5. Float or slack. Calculates the buffer time for non-critical tasks, allowing for minor delays without impacting the overall schedule. Benefits of CPM. 1. Improved project planning and scheduling. Provides a clear understanding of project complexity and dependencies. 2. Critical task identification. Identifies critical tasks that directly impact project completion time. 3. Enhanced resource allocation. Helps optimize resource utilization by identifying bottlenecks and prioritizing critical tasks. 4. Effective monitoring and control. Enables tracking progress against the schedule and identifying potential delays early on. 5. Increased project predictability. Improves communication and reduces uncertainty by setting realistic timelines and managing expectations. 6. Reduced project costs. Helps minimize downtime and optimize resource usage, potentially leading to cost savings. 7. Visual representation. Offers a visual representation of project activities and their interdependencies. Drawbacks of CPM. 1. Initial setup complexity. Requires careful analysis and creation of accurate network diagrams and estimations. 2. Data dependency. Relies on accurate task durations and dependencies, which might be difficult to estimate early on. 3. Resource allocation. It may not address resource constraints or resource leveling. 4. Assumed activity time. Relies on estimated activity durations, which may introduce variability. 5. Limited flexibility. Changes in scope or task durations can disrupt the schedule and require recalculations. 6. Software dependence. Often requires specialized software for effective implementation, adding an additional cost. 7. Focus on time optimization. May not account for other project constraints like budget or resource availability. CPM is best suited for complex projects with 1. Multiple interdependent tasks. 2. Tight deadlines. 3. Limited resources. 4. High risks associated with delays. 5. Need for accurate planning and monitoring. Examples include construction projects, software development, product launches, and marketing campaigns. What kind of projects can be managed with CPM? CPM can effectively manage various project types, such as 1. Engineering and construction projects. Planning and scheduling construction phases, equipment usage, and resource allocation. 2. Software development projects. Managing development sprints, dependencies between modules, and resource utilization. 3. Research and development projects. Planning experiments, allocating resources, and tracking milestones. 4. Marketing and advertising campaigns. Scheduling campaign activities, budgeting, and managing resource allocation. 5. Event planning. Coordinating tasks, resource allocation, and ensuring timely completion of event components. Overall, CPM is a powerful tool for managing complex projects, but its effectiveness depends on careful planning, accurate data, and adaptability to unforeseen changes.